So today we're going to look at an introduction into section 3.3. Section 3.3 is all about piecewise functions, but there's some things about sketching lines and how graphs move that I want to talk about before you actually get into section 3.3 to graph these things. I think it'll make our journey in this section a little bit easier. So if you were in class, I showed the video called Slope Dude. It's on YouTube, so for those of you that have not seen it, I would highly recommend. It's a 2-minute video. If you go to YouTube and look up Slope Dude, I think it's 2 minutes and 13 seconds or something like that. And I've tortured my students every year with watching this lovely Slope Dude thing, and it kind of sticks in their head and they remember. It's pretty funny. You'll see. So I'm hoping you're intrigued, and we'll go find Mr. Slope Dude if you haven't seen him yet. First thing we're going to look at is talking about equations of lines. So it says, and this is posted on our classroom page, the worksheet here. It says, given the points -1, 3 and -4, 0, find the equation of the line and graph it. Well, again, this is back to like what, Algebra 1 or something like that. You've got 2 points. You want to figure out what the equation of the line is. You need a slope. Thus, why you wanted to watch Slope Dude. Slope. Here it is. They use M, the letter M, to represent slope. You've seen that before. I don't know why they picked M. They just did. I'm sure they had some kind of a reason, right? So the slope formula says, hopefully you remember, y2 minus y1 over x2 minus x1. And here's the problem with lots of kids. They forget, should the y's be on the top? Should the x's be on the top? Who's on the top? Who's on the bottom? And so that question comes up a lot. And so here's a way that I remember it. Watch this. And you say, what's that? And I say, that's a picnic table. And so you've got a picnic table. The x's have to be on the bottom to support the picnic table. Now, forgive me, I know that we're in education here and trying to be appropriate, but you've got martini glasses on the top of the picnic table. There you go, slope formula. All right, so a way to remember that. The y's have to be on the top, the x's on the bottom. So in our case, take your points, label them x1, y1, x2, y2. It doesn't matter which ones you choose to be x1 and y1 or x2, y2. Just you have to label one of them. It'll work out either way. If I had picked this to be x1, y1 and that to be x2, y2, I'd get the same answer. So here it is. y2 is 0. y1 is 3. There's my top. x2 is -4. Minus x1's a -1. Now notice I put that in parentheses, right? Because I've got to distribute the negative. So on the top I get a -3. On the bottom I get -4 plus 1, negative, gives me -3, and I say, woohoo! I get a slope that is 1. But then you need a slope in one of the points. You go back and you check out your points. You're going to pick the one that's prettiest to you. You got -1, 3, you've got -4, 0. I'm going to go with a -4, 0 because I like 0. All right, so y equals mx plus b. I'm sure you remember that from back in the day. Your y is 0, your m is 1, your x is -4, and you're looking for the b. And so you're going to just solve it out. So 1 times -4 is -4. 0 equals -4 plus b. When I bring that 4 to the other side, I get a b that is 4. That's your y-intercept. And so the equation of the line is putting your b together with your m, and here it goes. Y equals m1 x plus b of 4. Now, probably you would see that written. We don't usually do 1x. It's just an x plus 4. They're one and the same thing, but normally you see it written this way. Then they say graph it, and you say, okay, no big deal. My y-intercept is 4. I go up 4, 1, 2, 3, 4. I put a dot, and then I use the slope as the rise over the run to come up with where the next point would be. So if I have a slope of 1, that means I rise 1 and go right 1. Rise 1, right 1 puts me here. Connect the dots, and there you have graphed that line. All right, number 2. Same idea. If I label my point x1, y1, and x2, y2, I can find the slope. y2, negative 3, minus y1, which is 1, over x2, which is 6, minus x1 is 2. I get negative 4 on the top, I get positive 4 on the bottom, I get a negative 1. That's my slope. Now I go back and look at the points. My choices are 2, 1, or 6, negative 3. I'm going to go for the 2, 1. And do my y equals mx plus b. Y equals mx plus b. My y is 1. My m is negative 1. My x is 2. And I want to find b. And so negative 1 times 2 is a negative 2. 1 equals negative 2 plus b. And when I swing that negative 2 to the other side, that comes to be a 3. So b is 3. Take your slope, take your b, put it together. Y equals negative 1x, negative x, plus 3. And then you want to graph that. So the graph goes with the y-intercept first. The slope is negative, so negative 1 means down 1 and right 1. And so here's my graph of this line. Alright, then we get into sketching graphs. The other thing that comes up with these piecewise functions is you need to know how to sketch all different kinds of graphs. And so the graph that we're going to look at is the graph of y equals x squared. And so y equals x squared is a happy parabola with its vertex at the 0, at the origin. If it were a negative x squared, it would be flipped upside down. It'd be a sad parabola. This guy's a happy parabola. But before we get into the next page of these examples, I want to know what happens if I have this. What if I had x squared plus 2? Think about how that 2 affects the graph. What's it going to do to my happy parabola? And you might say, that's going to move it up too. And you'd be right. It would be starting now with the vertex at 2 and be my happy parabola. But what happens, this might be a little harder, what happens if it's y equals x plus 2 squared like that in the parentheses? That is not an up move, right? An up move is when it's separate by itself outside of the parentheses, outside of the x squared. But when it's inside, that moves it left or right. And in this case, it's going to move it left. Now that might be counterintuitive to what you're thinking, because you might be thinking, geez, that's a plus sign, I should be going right. And I get why you're thinking that, because it kind of makes sense at some level. But here's a story. If I take x plus 2 and set it equal to 0 and solve for x, my x is negative. That means it's moving in a left direction, not a right direction. So because when I solve this, I get a negative, that's why it's actually moving left. Which means that if I had this, y equals x minus 2 squared, that's going to be actually moving right too. Again, it might be opposite of what you would think it would be, but that's really what it does. Well, let's put it all together. Let's do a hard one. What if I had x minus 3 quantity squared, and then I had a minus 1? What's that going to do? And that is going to move it right 3 from this part. And the minus 1 moves it down 1. Now here's something that came up that some kids were asking about. If I go back up here to this guy, what would happen if I FOILed that? If I FOILed x plus 2 times x plus 2, and you would get x squared plus 4x plus 4. And that's true. That is absolutely true that that's what it FOILs into. But the deal is, for graphing purposes, do you know exactly what the graph looks like for this guy? And I know you could find it. Remember back in the day you used negative b over 2a. Is that kind of ringing a bell when you did quadratics? And you could figure out where the vertex is and all of that based off of this equation. But this one that's equivalent to it is nicer because this one readily tells you exactly where it's moved. This one you can't tell. You can't tell whether it's moved left, right, up, down, whatever it is. But in this form, you can automatically tell that it's a regular old parabola that's been moved left 2. So we don't tend to FOIL these out when we're trying to graph them, because this form, which is equivalent, is the easier form to tell the movement of the graph. Okay, so although you might think to FOIL this out, you don't want to do that. Not for what you're trying to do when you're graphing them. All right, flipping over. So let's take all that and put it into play here. Number 4. How's this thing moved? Right? It's a parabola, square. This part here tells you left or right. This part here tells you up or down. So I know that this guy has moved right 3 and up 2, positive 2. So I go where the vertex is. Was it 0, 0? I'm going right 3 and up 2, and now my new vertex is here. And so I just draw a happy parabola right at that location. Same thing goes for number 5, except number 5 has this negative in the front, right? That makes it a little different. That negative, think about what that's going to do to your parabola. And hopefully you're thinking that instead of it being a happy parabola, it's now a sad parabola, and that's true. So this is going to flip it upside down. We'll call it a flip. Flips it over. The x plus 4 is going to move that left 4 because it's in the parentheses. The minus 3 is going to move it down 3. And so let's see from that information if we can graph this guy. If I start at the origin where it normally would start, I'm going left 4. 1, 2, 3, 4. Down 3. 1, 2, 3. Put a dot. And this one, it normally would have been a happy parabola, but because of the negative in sign, it's now a sad parabola. Just over here. How about though if I had the absolute value graph? Does that change things up any? Now we know the absolute value graph is a V, with the V happening at 0, 0 at the origin. But when you're sketching the graph, the same movements work the same way with the absolute value graph. So say, for example, I had this, y equals the absolute value of x plus 2, all in the absolute value sign. It works the same way as it did with parabolas with the parenthesis parts. So this guy here would actually be moving it left or right, and if it's a plus sign, it's left 2. So I would take my V and I would come over here left 2, and I'd make my absolute value graph. Same thing goes if I had the absolute value of, let's say, x minus 3 plus 1. This would move it right 3, and the outside 1 would move it up 1. So they work the same way as the parabola does, as the quadratic. Let's try a couple of these guys. Right, here we go. X plus 1 minus 3. Take a minute and think about how that's moved. See if you can graph it. So it's left 1 and down 3. Start at the origin, left 1, down 3. 1, 2, 3. Puts it here. Here is my V, my absolute value graph. And the last sketching one, this one has a negative in the front. Think about what that's going to do to your V. X minus 5 is a right 5. Plus 2 is an up 2. Let's try that first. Start here, let's go right 5, 1, 2, 3, 4, 5, up 2. But it's got to be upside down because of the negative. It flips. My V is now fallen over. All right, last thing before I show you the next type of problems that I want to get into with piecewise functions. This is a big debate. And in class, we had lots of kids that had different opinions on what this answer should be. Should it be a positive 9 or should it be a negative 9? If I take negative 3 squared, does it equal 9 or does it equal a negative 9? So I had half the kids that said positive 9 and half the kids that said negative 9, interestingly enough. This is a classic SAT type question because they know that kids forget this, that this is a struggling place for kids. So, here's the story. Do you have an opinion yet? 9 or negative 9? Answer is negative 9. So, here's why. You have to remember the order of operations. So, in the order of operations, please excuse my dear Aunt Sally, you've got exponents that come before multiplying. So I have to square it first and then times it by the negative 1, the negative sign, which is why it's a negative 9. So it's all because of PEMDAS. Please excuse my dear Aunt Sally. It's all because of PEMDAS that it actually is that negative 9. And I can tell you, you need to be smarter than your calculator, because a lot of times if you put this in the calculator, it's going to spit out a positive 9. And you have to be smarter than your calculator, because I don't know why the calculator does it, but it does. A lot of times there's little blue calculators that we tend to use. For whatever reason, they tend to tell you it's positive 9, but it's not. You need to be smarter. So it's actually because of PEMDAS, it's actually a negative 9. So that might be mind-blowing to some, but that's really the rules for how that works. All right, so that's the first worksheet that I wanted to look at today as an intro into this section 3.3. There is a second worksheet that I want to look at. Let me find it. Here it is. All right, so it looks like this. This again, it's posted on our classroom page. So piecewise functions, they're made up of 2 or more functions, each with its own domain. So in other words, it's kind of split. You've got all this graph is going from negative infinity to 0. Remember, you're talking about the x values. And then it picks up again at 0 and goes to positive infinity. So it's in pieces. It's a piecewise function. Makes sense. Let's think about what the equation would be for these guys. And these are lines. We know lines are y equals mx plus b. So it's all about what is the m and what is the b. So if I look at this one that's on the left, this guy on the left, he has a b of negative 1. All right, so we know we got y equals something mx plus b. Now b is negative 1, so it's going to be minus 1. The question is, what's the slope? Well, the slope is the rise over the run. So you need to see if you have some coordinates that go perfectly through. Here's one here, goes perfectly through, so I can figure out what the rise over the run is. Rise is 2, run is 3 to get to the next good coordinate. So I've got 2 over 3, and then I need an x, right? Y equals mx plus b. Second line. Second line now has a y-intercept of 3. Y equals something plus 3. It's positive 3. Well, what's the slope? If I go from here to the next coordinate, it's down 1 and right 1. It's a negative slope, so it's going to be a negative x, negative 1x plus 3. But the line doesn't go for forever, so there has to be some inequality statement with these attached to show that the line stops or starts in different places. So this one here, all of my x values are less than 0. Everything is less than 0. They're all to the left of 0. So this guy, and not equal to, by the way, because of the open circle. So this part is going to be x is less than 0. And you're always going to see some kind of an inequality statement on these piecewise functions. This one starts at 0 and is bigger than 0. You have x values that are always getting bigger. So you've got x is greater than, closed circle, equal to 0. And there are your equations for these two, for the picture. Now they ask you to find f of 0, f of negative 3, and f of 4. So you have 2 equations to choose from. You're only going to use one. No matter what, whenever you're looking at these, Even if they give you 10 equations, you're only using one. So you got to pick which one works for the situation that you have. So f of 0 is the first one we want to find, f of 0. All right, so I'm going to look at this. Do I use equation number 1 or do I use equation number 2? And it's based on where the 0 would fit. Is it part of this graph? And it's not, because remember, it's not equal to. It's actually part of graph number 2, the second equation. And so that's the one that I plug it into. So I get negative 0 plus 3. I get an answer of 3. Well, let's check it on the graph. If I'm at 0, what's the corresponding y value? If x is 0, y is 3. It makes sense. The next one we have is f of negative 3. We have two equations to choose from. Is it part of this or is it part of that? So I've got to check out the inequalities and see which one works. So if I look at this, where is negative 3? Is negative 3 less than 0? And we say, yep, it is. So therefore I'm going to use this top guy. So I have 2/3 times x, negative 3, minus 1. Now if I do the math of that, that's negative 6 over 3, or negative 2. Negative 2 minus 1. So my final answer is a negative 3. Let's see if that works on the graph. Is that really the coordinate? If I'm at negative 3, my y value is negative 3. There it is. So we got that one right too. And the last one's f of 4. So I'm looking at f of 4. Where is 4? Is 4 part of this or part of this? Is it less than 0 or greater than or equal to 0? And you're going to say it's greater than or equal to 0. It's 4. So you're going to plug it into the second equation only. That would be a negative 4 plus 3 gives you a negative 1. Is that true? Let's check it out. If I'm at 4, I get a coordinate of negative 1. So in that one we were able to check our answers because we had the graph of them. The other examples I'm going to show you don't have the graphs. So we're going to try some without graphs. All right, next set. I have now three equations. One of them goes when x is less than negative 2, less than or equal to negative 2. One of them goes between negative 2 and 3, including 3. And one of them is when x is bigger than 3. So, where's negative 4? Is negative 4 part of equation number 1, 2, or 3? Again, you're only using one of them, even though there's 3. So negative 4 would be less than negative 2. I'm using this first one. That is 2x plus 8. Well, my x is negative 4. So you plug it in. And then you math it out. So you got negative 8 plus 8, and you get a value of 0. If you come to the next one, it's 6. Which one of these does 6 fall into? Is it less than negative 2, between negative 2 and 3, or greater than 3? 6 is greater than 3. I'm using this guy. This guy is the square root of my x, 6, plus 3, or the square root of 9. The square root of 9 is 3. Now it's only the positive part because they only included the positive part here. I know it's a little complicated, but it really is just the positive. Then I get negative 2, next one. Is negative 2 part of equation number 1, 2, or 3? Well, negative 2 is actually equal to where it's not equal to here. So I'm going to use equation number 1. 2 times negative 2 plus 8 gives me negative 4 plus 8 gives me 4. And then I'm going for 0. If I'm a 0, where am I? Am I less than 2, between 2 and 3, greater than 3? I'm in the middle. So I'm going to use the middle equation, x squared minus 3. 0 squared minus 3 is just a negative 3. So don't let these intimidate you, even though they look big and beefy and meaty. It's just you pick one. You pick the one that works for the x value they give you. And you notice too that this inequality part is only telling you which equation to use. This doesn't come into any of your calculations when you're actually calculating out the value. It just tells you which equation you want. All right, we're going to try these and then we'll call it a day. This one's kind of interesting because you've got a cubic for the first guy and you've got 3 for this one. That means there is no x. There's no place for you to plug anything in. That if you're between 1 and 5, your answer is just 3. It's just 3. And then you have an absolute value for the last one. So let's try these. If I'm an 8, where am I? Am I less than 1, between 1 and 5, or bigger than 5? I'm bigger than 5. I am the absolute value of 8 minus 2.
Pardon the interruption. Once again, a reminder to please wipe down your desk and area before leaving class. Just a reminder to please wipe down your desk and area before leaving class. Thank you.
Okay, so I am a value of 6. If I'm 0, where am I? Am I less than 1? Am I between 1 and 5? Am I bigger than 5? I'm less than 1. I'm using the first guy. 2, 0 cubed minus 1 gives me a minus 1, right? 0 cubed, again, please excuse my dear Aunt Sally, 0 cubed is 0 times 2 gives me 0, and 0 minus 1 is a negative 1. Then I'm a 4. Am I less than 1, between 1 and 5, bigger than 5? I am between 1 and 5, therefore my answer is 3. There's no calculating to do, there's no x for you to replace it with. And then last one, f of 5. Which one am I choosing? I'm definitely not less than 1. Am I between 1 and 5 or bigger than 5? It all has to do with the equal to sign. I'm using the last one because that's the one with the equal to. So it's the absolute value of x being 5. I should have a 5 there. Right? 5 minus 2. And the absolute value of 5 minus 2 is 3. There you go. Alright, so your task is to finish numbers 1 through 6, the next page, which by the way has some problems at the bottom. Let me just real quick show you those, or at least one of those. This is from a graph. They're giving you the graph, no equations, or they give you equations with these guys over here. This is just what's the coordinate. If I go to -1, what's the coordinate that goes with that? What's the y value? This one would be 0. If I'm at -1, I'm looking at this point right there, and that point has a y value of 0. Alright, so your task is to work on numbers 1 through 6 from this practice worksheet. Shoot me an email with any questions.